Hello and welcome to this demonstration on the functionality of Deep Exploration 6.0. I'm going to spend the next 20 minutes or so giving you an insight into how this software works and showing you what stunning results you can get from your CAD models and how easily you can share your designs and CAD information with other people. The subject of this demonstration is going to be the set-top box you can see on the screen at the moment. As you can see, it's quite a detailed model. This design was originally developed in Inventor and has been imported into Deep Exploration. Deep Exploration will seamlessly import a huge variety of CAD formats including Pro Engineer, Inventor, SolidWorks, CATIA and numerous others. As we can see here from our information panel, this assembly contains just over 60 components and is about 3 megabytes in size. Up here we have the scene tree. All the components are named and listed as per the native file format. Folders represent sub-assemblies and you can easily hide and unhide components from the main viewport just by checking or unchecking the box next to the component. So I can easily hide off some of these components, and here we can see inside the product, which features a couple of PCBs, some connectors and some mechanical fixings. Now it might be the case that someone is looking at this file for the first time and is not familiar with the design. For this reason, Deep Exploration features a pull apart tool. This tool allows users to pull components away from the main structure and place them anywhere in the viewport. As you can see here, I can just grab those components, and once finished I can easily return to the home position. As you would expect from a CAD visualization tool, there are many different ways to view this model on the screen. Users can quickly toggle between a variety of modes, including bounding box, solid view, transparent, wireframe, technical illustration mode, which we'll cover later on, shaded view, shaded outline, and a couple more bounding box options. You also have different ways to display the model within the viewport. Depending on the CAD system you are used to, you could take advantage of a split 4-window viewport or a stacked view. For this demonstration I'll just use a single view layout. You can also quickly and easily access different default views of the model based upon its orientation. So keyboard shortcuts allow me to quickly access R for right hand view, T for top, B for back. I also have the ability to toggle on and off perspective view and to toggle on and off the shadow. Now I'd like to go through 4 different aspects of the system in this demonstration, and they are markups, animations, renderings and technical illustrations. Deep Exploration has a tab system at the top of the screen which allows you to categorize your toolbars and create a workflow depending on what output you are trying to create. As you can see here, if I access the markups tab, then I have access to all the toolbars available which are relevant to creating and viewing markups. Within the design process, markups are extremely important. They allow engineers to communicate designs to each other and engineering managers to provide feedback and validation of designs. Deep Exploration has an extremely comprehensive markup ability. This tab on the right hand side allows the user to save a snapshot or model view of the model. I've previously created and saved some markups that can be seen here on the screen. This snapshot draws attention to a clash of components, and this one makes reference to some ECAD data. These markups contain notes, sketches, images, comments, dimensions and detailed views, all the aspects that are required from a markup tool. I'm going to go ahead and create an example of a markup so you can see how easy it is to create them, and then I will show you exactly how these markups can be used once they've been created. One of the problems with some of the markup tools available within the CAD systems is that they use the actual engineering CAD models for the markups. So this means that people need a CAD license just to comment on a small aspect of the design. An added advantage of using Deep Exploration for markups is that there is no danger of a non-CAD user playing around with the engineering models they don't know how to use, which could end up in an unauthorized change being accidentally made. I've simply created a dimension here and hidden one of the main casings and added a detailed view to draw attention to the fact that an aperture is needed for the stand. If required, I could also create angular dimensions or calculate the surface area or volume of various components. Now that these details are created, I can create a simple note to convey to the person viewing this exactly what the problem is, what needs to be addressed. I can make use of several functions for creating notes in Deep Exploration that include notes with or without leaders and varying leader end styles, simple notes without leaders, and also any digital image can be pasted into my markup. Finally, I'll just toggle off the grid here and the shadow, and I can add the view to the list of other markups. If required, I can go ahead and change the orientation of the model in that snapshot and just quickly update it. I also then need to make sure it has a logical name so that people realise the nature of this markup. And I can also specify here how long the system takes to orientate to this view. And that's my markup completed. If I go back to my standard view, I will then access the new markup, and we can see that all this detail has been captured. I'll now go back to my standard view and save this model, and we can take a look at exactly how these markups can be used and how the markups can be conveyed to engineers or other departments and other companies and clients. Deep Exploration has a free viewing tool called Deep View. It comes with a system or can be downloaded from the website. And this allows people without a license of Deep Exploration to view files and view markups and amend or create markups for use within the system. This is the Deep View interface, and I can simply drag and drop our file into the viewport and wait for it to load up. You'll see that visually Deep View looks very similar to Deep Exploration as I orientate the model around. You can view the model in different modes as in Deep Exploration, for example wireframe or technical illustration. And Deep View also features a cross-section tool so that users can easily interrogate the internal aspects of a design for fit and function. On the left-hand side are various other tools. We have the ability to see and access the scene tree exactly as per Deep Exploration, but most importantly for us is the ability to see those markups which we've just created. You can see here on the right-hand side the thumbnails of those markups, and exactly as in Deep Exploration you can click on them and view that particular markup. We can see here the one that I just created, and I have the ability to amend that markup or create others, and then save back to the native Deep Exploration format so that those comments can be seen by others. So that's an overview of markups and how they can be created and used within Deep Exploration, and additionally how they can be used using the free download Deep View. The next area I'm going to cover is how to create animations within Deep Exploration. This panel on the right hand side called Steps and Procedures deals with animations. Now I've already created some short steps here that show the assembly process of this product for use in a factory or assembly environment. Animations can be a very important tool for designers. They can be used to clarify and validate how mechanical designs work, or they can be used for marketing, or as we can see here, manufacturing or assembly purposes. These animations that I just played are just a set of short, simple sequences that you can see listed here. If I activate one of these sequences and move the animation slider at the bottom of the screen, you can see the movement involved in that sequence. These sequences are really very simple to create, and I will show you an example of creating a sequence and then how to group these sequences together to create a longer, more detailed animation. With this product, the sub-assembly on the right hand side of the screen with the green casing needs to be lifted and assembled onto the other casing. So I can just create a new sequence here on the right hand side, and then go and give it a logical name, and I can specify the length of this sequence, so in this case I'll choose to make it 2 seconds long. So now all I have to do is simply record what I'm doing on the screen. I'll just slide the animation slider to 1/3 across and then hit record. So here I'll select the sub-assembly and then go to my animations tab at the top, and we'll just move this sub-assembly up from the ground plane. And then we want to rotate it 180 degrees, so I'll select the rotate tool, and we can see how many degrees I've turned it up in the top right hand corner there. And all I'll do then is stop recording and move the slider to 2/3 across, and then record the next bit, which is moving it across to the other casing. I can switch views at any time to get a better look at what I'm doing, and then once it's in position, like so, I'll stop recording for the final bit. So I'll move the slider to its final position, start recording, and then we need to bring the casing down to its final position. So just make sure that's in its correct position, and that's finished. So now I can play that new sequence from beginning to end, or I can simply use the slider to slide it back and forth like so. I can just reorder these sequences by dragging and dropping them. It's not required to have them in the correct order, but it does make things more logical to look at. I'll then go back to the Steps and Procedures tab, and I can group these short, simple sequences together to make a more detailed animation. I'll create a new step and give it a name, and I can add some assembly instructions to come up on the screen when this step is playing. I could also annotate these animations with symbols or logos. For example, arrows further indicating where a component is placed or highlighting areas where common mistakes can be made. I then simply add the sequences I want to feature in this step, and at this point I can also reorder them if I want. Then we can also say here that whatever orientation the product is in when I play this animation, it should take 2 seconds to fly to the view of my choice. And this is something that makes the animation look really nice when it transitions from one step to another. So once that's done, I'll just update the position in which this step is viewed, and to do this I'll just run the previous step, and then reorientate just to get a better view of the detail and what's happening in this final assembly step, like so. And then I can play all of these steps together. Firstly, we can see the layout that the person assembling this product should have on their assembly desk, and then the final assembly process. And we can see here the transition between steps taking 2 seconds to fly to that new position that we specified. So as I mentioned before, this could be used by many different departments within a company to educate people or show people how designs work, or how they are assembled or disassembled, or quite simply to convey conceptual designs to other designers. And at any point the viewer can stop the animation and go and interrogate the model to look at certain areas in even more detail. These animations are also viewable in the free-to-download application Deep View, which we saw earlier on when we were looking at markups. So finally, this set of steps could be output and saved as a fully rendered photorealistic file, the most common of which would probably be the AVI format. So that's a quick overview of animations and how they can be created and viewed. Next area I'm going to cover is how you can create photorealistic renderings within Deep Exploration. I'll go to my rendering tab at the top here, so I have access to all the relevant toolbars. Now if I hide this top casing, we can see there are lots of internal components which wouldn't be seen in a rendering and use up valuable processing power when creating renderings. There is a specific tool here to remove internal components. So if I activate that tool and process the data and then hide the top casing, then we can see those internal components are gone. And this will improve our rendering time later on. Deep Exploration comes with a library of high dynamic range materials that you can see here, and to apply these materials it's as simple as dragging and dropping them onto the components. So I'll add some materials to this product to make it look more realistic than the standard CAD colours that came when this file was imported. So a gloss black there for the main upper and lower casings, and a beige plastic for the side casings, and we can just add a rubber material for those feet. These materials are extremely detailed files and contain a huge amount of data. We can see here, if we look at the properties of this gloss black, the type of materials it is, the type of finish we can choose, and here we can see different maps can be specified. For example, a 3D texture could be specified as a bump map. And further detail can be applied to the part regarding materials. We can UV map these materials onto different parts. If we look at the properties of this switch, we can see how the system can unwrap that part into 2D, so it can more accurately calculate the light reflections on that component. So once that's done, we can change the rendering engine used in the viewport. This menu in the bottom corner shows the ones available, and I'm going to switch to the high dynamic range real-time driver. High dynamic range is basically a set of techniques which allow the computer to more accurately calculate light definition, and it's this light definition that ultimately is going to give our image its photorealistic quality. Now with the high dynamic range renderer comes something called environment maps, and environment maps are basically 360-degree high definition images with lights built into those images, and to use these you simply drag and drop them into the scene. So here we can see an example of an environment map, this lawn scene. It's not really suitable for this product, but straight away you can see it makes those materials much more realistic. So for this rendering we'll choose one of the many studio environments that's available in the Deep Exploration library. And I'll just simply orientate this product into a position we want for the rendering, like so. And then we can take a quick look at the rendering properties. So here we can see all the different preset sizes you can choose, and you can specify things like resolution. And we can see here there's a slider for the overall quality of the image. Now I've left this on a fairly low image size and resolution and picked a draft quality so that it renders quite quickly. but later on I'll show you some images of this product where the settings and resolutions were ramped right up. I've just selected the render icon, and this should take a few seconds to render this image. So that's our final image there, and for a quick draft image it's really of a very good quality. You can see the depth in the plastic on the sides, and the reflection in the paint on the top is particularly good. And it's these high gloss and metallic materials that are notoriously difficult to render in other rendering packages. So this product also has a stand, so you can use it in an upright position. I'll just go and find that stand in the scene tree and unhide it, so you can see it on the bottom there. And what we just need to do is reorient this scene so that we can see it in that stood up position. So I can change that ground plane from Y to Z, just in my scene properties. And then what I'll do is just take that entire assembly and use the rotate tool to just rotate it around 90 degrees. So again you can see those degrees up in the right hand corner there. And just make sure that that is sat on that ground plane, like so. And we just tweak this slightly, so move the entire assembly up and that stand down a little bit so we can get a better look at it. Like so. And then the final thing to do here is just add a material onto that stand. So a metallic finish for this one, use a stainless steel. Like so. So a further thing we can do is use any digital image as a background. I have a simple JPEG image here of this desk and monitor. And so what I'll do is use the studio environment map to get the lighting correct, and then just drag and drop this image as the backdrop. I'll use the scale tool just to scale it up there, just make sure it's within the boundaries of my rendering, and then just reorient this product and put it in the correct view for this scene, like so. And then I can just set that rendering going, which again will just take a few seconds. So here we can see that final rendering. As you can see, it's a great tool for getting an idea of what your product looks like in its natural environment. So I have some examples here of the product where the rendering settings have been ramped right up, and these only took 10 or 15 minutes each to render. So here is the first one that we did, and here's one of the products stood up with a white casing, and here's a simple JPEG image as the backdrop, the one that we rendered here. And again at the end here, a couple of examples of how you can quickly and easily explore different colour schemes with this rendering engine. So that's an overview of rendering within Deep Exploration. You can get some amazing results from your CAD data without having to pay for expensive prototypes and photo shoots. So the final area of this demonstration I want to cover is technical illustrations. I'm just going to reload this model so we can see it without the new materials and without that stand, and back in its standard orientation. And then I'll just go to the technical illustrations tab, like so. I'm just going to prepare this model to create a technical illustration. Now, technical illustrations can be used for many different things, such as user guides and instruction manuals, and can be very expensive to produce if you need professional illustrators to draw products from scratch. With Deep Exploration, you can just use your CAD data to quickly and easily create your technical illustrations. Now with our model here, I've just hidden a couple of the casings and moved a couple of the screws down, and then toggled the grid and shadow off. And I can just simply go to technical illustration mode to view this model. Now there are a few things that are characteristic of technical illustrations. The first of these are callouts or part balloons. I can simply select a few of the parts as I've done here, and then go to my parts tab, and then just simply create those callouts, like so. And if I go to the settings of those callouts, then I can specify the nature of them. So I can change the part name, I can change the balloon shape or size, and I can specify different leader types as well. The second thing characteristic of technical illustrations are thrust lines. Again, very simple to create. I can simply select this screw and then select the casing, and then go to the thrust line tool, and there's that thrust line created. So I'll just do exactly the same for these two other screws, like so. Again, now the great thing here is if I move these screws, then we can see that that thrust line updates. So wherever my model moves in the future, then my thrust lines are always going to be in line. One more thing is detailed views. So we saw these when we were looking at markups earlier on. And again, very simple to create. We just select the tool, drag a circle around the aspect that we want to create a detailed view of, and then drop that balloon. The one great aspect is the ability to change the view of the detail here, and as you can see, the entire model is embedded in that view, so I can just turn it around and tweak it, have it any which way I like. I can also look at the properties of this balloon, and we can see that I can change to an arrow leader, or I can change the colour of the border. So finally we can just render this image. You have two choices here. You can either render as a vector image or a raster image. So firstly we'll render as a vector image. I'll just save this to the desktop, and we'll be able to view this in deep view, and here you can control those thick and thin lines. I'll just drag and drop this into deep view, and there's our image. As you can see, I can select all of these different lines, so if required I could take this image and edit it. If we go back to deep exploration now, we want to create just a simple raster image. So again, I'll go to the raster image renderer and just set that going. So this can be simply saved as a JPEG or PNG, as you can see here, and then drops into our technical publication document. So I'll just cancel this and get our product back to its standard orientation. And that brings this demonstration to an end. I hope this has given you a good insight into the capabilities of deep exploration and shown you some of the great results you can get from this system and from your existing CAD models, and just how easy this system is to use.